Have you ever thought about how life gets started? It's pretty amazing, right? Well, it turns out nature has two completely different, kind of opposite blueprints for making it happen. On one side, you've got this super secure fortress-like strategy. And on the other, a strategy that's all about numbers, basically casting fate to the wind. Today, we're diving into both, internal versus external fertilization.
So, yeah, how does nature solve this giant puzzle? If you think there's just one way to do it, you're in for a surprise. As you're about to see, the answer has everything to do with where an animal lives and, well, what kind of life it leads.
All right, first up, let's talk about what I'm calling the inside strategy. This one is all about playing it safe. It's about creating a secure, controlled environment to give the next generation the absolute best possible start in life. The name pretty much gives it away, right? Internal. This means the big moment when sperm and egg meet happens safely inside the female's body. Think of it like a private, protected incubator, totally shielded from all the dangers lurking in the outside world. And you can see how all these features are connected. Because everything happens inside, there's way less risk of the sperm or eggs just getting lost or eaten by something. This gives the embryo incredible protection, which naturally leads to a much higher survival rate. The only catch? You gotta find a partner and go through the whole complex process of mating.
So who uses this strategy? Well, a whole bunch of animals you know, including us. Mammals, birds, reptiles, they all rely on this internal blueprint. It really gives their offspring the best possible shot at making it.
Okay, now let's completely flip the script and look at the outside strategy. This approach takes a totally different kind of gamble. It puts all its trust in the wide open environment and, you'll see, the power of just overwhelming numbers. Yep, this is the polar opposite. Here, the fusion of sperm and egg happens outside the body. And for this to work, you almost always need one special ingredient: water. Water acts like a giant highway, letting the gametes travel around and, hopefully, find each other. This strategy is a total numbers game. I mean, because the whole process is out in the open, exposed to predators, currents, and just pure chance, these animals have to release a huge amount of eggs and sperm. With no protective environment, there's way less protection for the embryo, and you guessed it, a much, much lower survival rate for any single one.
So who's playing this game of chance? Mostly, it's our aquatic friends. Just picture a school of fish releasing these massive clouds of eggs and sperm into the water, or frogs laying thousands of eggs in a pond. They are the absolute masters of the outside strategy.
Okay, so we've seen both blueprints for life. Now for the fun part. Let's put them side by side, head to head, to really get a feel for the major trade-offs each one is making. This is where you can really see the differences just pop. Let's break it down feature by feature. This table really lays it all out, doesn't it? Look at the place, inside versus outside. That one little detail has a huge domino effect on protection and, of course, the survival rate. Then there's the environment. Internal fertilization basically allowed animals to conquer land because they didn't need water for reproduction. The external strategy, it's pretty much tied to the water. And the examples just say it all. Humans and birds on one side, fish and frogs on the other. Two totally different evolutionary paths. So, after putting these two amazing strategies under the microscope, what's the bottom line? What's the one big idea you should walk away with? Here's the most important thing to get. Neither strategy is actually better than the other. They're just different solutions to the same problem. Internal fertilization is like a low-volume, high-investment plan. It's quality over quantity. External fertilization is the opposite, a high-volume, low-investment gamble. Each one is perfectly adapted to the animal using it and the world it calls home. So in the end, when we look at these two methods, we're seeing more than just biology. We're really seeing millions of years of evolution playing the odds, constantly balancing risk with reward. And it leaves us with this really fascinating thought. What do these two very different blueprints for creating life tell us about all the other countless trade-offs that survival demands?